TikTok. I love puns. Like, I'm a tick magnet. Ticks dig me. Let's have a TikTok. I just enjoy this. Okay, look at them ticks. Woo-hoo-hoo! Tick, 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 tick. We are talking about the black-legged tick, also commonly known as the deer tick. Now, what kind of name is this one? Scientific name. Two-part scientific name. Ioxid scapularis. Ioxid scapularis. Now, oxodes. I've always heard ioxid tick. Though looking at it, it doesn't sound right, but that is honestly the way my professor in college, who I had for invertebrate and entomology and all that, he said ioxid tick, so I say ioxid tick. I think it's actually wrong. But I'm going to pass on that to you. So ioxid ticks. Ioxid scapularis is our little black-legged tick we find around here. This part of the name is the what? Do you remember? Talk at your table. Talk to one another. What is that? Genus. That's the genus. There are other ticks in the same genus. We'll talk about them in a little bit. So then this part is the species. Yes. Species. That is the only tick with the same first and last name. So Ioxid scapularis is our little black tick, our black-legged tick. We mostly call it the deer tick around here. And it is teeny, teeny, tiny. Where'd my little friend go? You guys have seen my little friend. I'm happy to pass my little friend again around if you want. That's probably a nymph, I would guess. You can pass my little friend. And they're an arachnid. How many of you thought prior to looking it up that arachnids were only spiders? Okay, it's pretty common. They are one type of arachnid. Arachnids are spiders, ticks, and mites. So if you have chickens, and I know a few people have chickens, chickens get mites on them. If you have bees, maybe somebody is a beekeeper or knows a beekeeper, there's the varroa mite. Those mites are also arachnids. So arachnids are a little bit different than insects. They have 8 legs. They have 2 body segments. Oh, shoot, what's the other bit? Well, darn it, that's enough for now. Daddy longlegs are arachnids, but they're not spiders. Ticks are arachnids, but they're obviously not spiders. They're a tick. Mites are arachnids. So they're not an insect, and it's a classification thing. And they're a parasite. Anybody here ever been called a blood-sucking parasite? Somebody quoted a movie yesterday, something about lawyers and blood-sucking parasites. I can't remember who that was. Ticks are literally a blood-sucking parasite. What is a parasite? You looked it up, but you might not remember. Well, it makes a living off others, and it hurts them in the process. It actually harms them in the process. Do you remember what para meant in your prefixes? You could have your vocab out while we're doing notes. So para was like near, beside, or equal. These things travel alongside. They travel with. They travel with another organism. They travel alongside. They travel with some other creature. That creature is their host. We're going to talk about hosts in a little bit. But parasites make a living off of hurting others. You can think about the next time somebody calls another human a parasite, are they really? Are they making a living off of hurting others? If the answer is yes, then yes, they are in fact a parasite. So it's a relationship, in a parasitic relationship. One organism is getting benefits out of it. The tick is making a living. The other organism is actually being injured. And ticks can do some good injuring. Very serious injuring. So these little ticks will prey on, and actually I just read that they sometimes prey on lizards, which I did not know. I thought they only preyed on mammals. Most commonly, they prey on mammals, and it's everything from mice, deer, and you, and me, and your dog, or your cat. They also prey on birds. That is the one other group that they will bite. And I didn't realize that deer ticks did spend more time than I thought on birds. But mostly birds who are ground nesting, because these little guys are limited to the ground. They don't have any wings. So they have a multi-stage, multi-year life cycle. And when we talk about life cycles, a lot of kinds of organisms have life cycles. You really don't. Who here has seen a new human? Relatively new. That would be a baby. I'm going to assign you homework. As you go up to random people in the store and say, "Can I look at your new human?" Don't shake the tick at her. So humans are born with the same number of arms and legs they're going to have as adults, same number of eyes and same nose, same general configuration. The only thing that really changes with humans as we grow is we get bigger. We get to be bigger, less adorable versions of the same thing we started out as. Seems like it's all kind of downhill, doesn't it? We're really cute. Well, not immediately we're cute. But anyway, these guys start out looking fairly different. And that's common with organisms that have multiple stages in their life cycle. So in a life cycle, we're looking at actual different forms over the period of life. Humans don't have a life cycle, we just have a lifetime. So in a life cycle, we're actually talking about different forms over life. And for ticks, for deer ticks, for black-legged ticks, this takes a couple years. They are native to the eastern U.S., but we're going to talk about whether or not they've always been in Ohio. A lot of you thought they haven't. Some of you think they have, but maybe you just never saw them before. And we'll talk about their range. There's an eastern and a western species. They are vectors for a number of diseases. What that means is they pass on diseases. Now there's one for these guys that's more important than any others, but all tick species are vectors for disease. All of them. There are dog ticks and wood ticks and other kinds of ticks, and there's the Lone Star tick, which transmits Rocky Mountain spotted fever. There is the AGA, granulocytic anaplasmosis. There's babesiosis. I'm not even sure what those diseases are. It would be a research project for me to figure that out. But all ticks can transmit disease. Not all ticks do. Not every individual tick. But all ticks are capable of being a vector for diseases. And a vector is just something that passes diseases from one species to another. They act as a go-between. They're the messenger. They are the drug mules of the disease world. They're carrying diseases, and they pass them. Ah, spring! Spring! And an egg's mind, if you can call it that, turns to thoughts of hatching. So in the spring of the year, and this is, it depends, but by May the ticks are going pretty good. The eggs are going to hatch, and they're going to hatch into larvae. And this is happening in April, May. You might find a few new larvae in June, but it starts to die down pretty fast. Usually April and May is when they hatch, around here anyway. And that varies, of course, based on where you are. It is temperature dependent. The larvae come out starving. They come out hungry. And the first thing they are going to do is look for what we call a blood meal, which is just what it sounds like. It is a tasty dinner made entirely of blood. Now, what's interesting, boy, you can't see it on here. The larvae only have 6 legs. They don't get their last pair of legs until they're nymphs, which is the next stage. So the larvae immediately find a host, and it's got to be something small and close to the ground. Mice are the most common host. And the host is the one the parasite is hurting. It's getting benefits from, but it's hurting. So they latch onto a mouse, they dig their nasty little mouth parts right into it, and they start sucking. Because they are a blood-sucking parasite. They get nice and fat and swollen with blood. And they get so big and fat and swollen with blood, and they get enough calories and enough nutrients, they do what's called molting. Does anybody here have snakes at home? Nobody, okay. Okay, you do. So do you know what it means to molt? Okay. Snakes molt, insects molt, they shed their skin. So who here as kids played with the little, or threw them at your siblings or your neighbors or your cousin or whoever else, the little things that you find on the bottoms of trees that look like they're split open and people say, it's from locusts, it's from locusts. You know what I'm talking about?
Yes.
They're actually cicadas, and that is the former exoskeleton. So they come out of the ground, they're big enough, they burst out of their old skin, they leave the old shell behind. Ticks do the same thing. Ioxid ticks do the exact same thing. They molt. They shed their old skin, they get a new skin, now they have 8 legs. Yay! They're nymphs now. They've gone to the next life cycle. It takes a blood meal to get them there. And then they just go dormant. They chill. They spend the entire fall and winter not really doing a whole lot. Dormancy is when you aren't necessarily going to be able to get enough calories, so you kind of go to sleep. Hibernating is a form of dormancy. And there are other forms of dormancy that aren't quite as extreme. But those nymphs go dormant. And in the spring, if you look at that little tiny larval tick, do you see? That's a dime. Anybody got a dime in their pocket?
No.
I don't think I do either. Look at the letter M on that dime. The larval tick is smaller than the letter M, significantly. Good luck seeing that. I have actually seen, oh, you have a dime. Okay, you don't have to pass it around. But just people at your table can take a look at the little tiny letter M. You're talking about something that is smaller than the letter M on a dime. They're very hard to see. There's some good news about that we'll get to later. It's not so terrible that they're so hard to see. Okay, so they hatch, they're hungry. You're teenagers. Many of you are in sports. How many of you wake up hungry? Are you kidding? They're beating me up in softball conditioning. They're making me swim miles in a pool and hold my breath and chase cars. I'm doing suicides in basketball. I'm running up hills. Yes, I'm hungry. And, you know, we got brain development going on. So these larvae, they hatch out hungry, they get a blood meal, and then they kind of go to sleep. Call it a food coma, if you will. They go dormant for a while. Well, then, of course, they wake up. So the second year, so a whole year after they hatched out of their little egg, the nymphs, because now they're a nymph. There's our little nymph. They're still pretty little. So once those nymphs wake up after their sort of hibernation, a year after they hatched out initially, they start looking for hosts. And these can be large or small hosts. I have pulled plenty of nymphal ticks off myself. I suspect that my little friend here is a nymph. It's about the right size. It does have 8 legs. It's too big to be a larva. It's too small to be an adult. I guess it could be an unfed adult. I'm not sure. I have to do a little bit more measurement. But those nymphs, again, go out looking for a meal. And they take a blood meal. So they bite something, they suck blood, and they drop off. You don't see them again. and they kind of relax for a while. They crawl around. They do their thing. They don't eat again. Can you imagine only eating 3 times in your whole life? Woohoo! I'm so excited. It's my day to eat. We don't work that way. They only eat 3 times in their life. So they hatch, they eat, they go dormant. The next spring, they eat again. So wait, they hatch, they eat, they go dormant, they change. Or I'm sorry, they hatch, they eat, they change, they go dormant. They wake up, they eat, guess what happens? They change! They got enough calories to change. They got enough calories to grow. They got enough energy that they just pulled in. So they feed, and then they kind of reorganize, and they emerge as adult ticks. And then in the fall, those adult ticks are going to take a meal. So the nymphs are going to feed in the summer, the adults, and we went to Clear Creek State Forest up near Cook's Forest last fall. The weekend we had parent-teacher conference, and we had the 3-day weekend. My family and I went up to Cook's Forest. Yay, let's go. Take the dog, take the kid. Let's go hiking in the fall. It's beautiful up here. It was beautiful. It was absolutely gorgeous. We got the canoe. We enjoyed some hiking. The number of ticks that we pulled off, all of us combined, and these were adult ticks. These were deer ticks, and they were adults. I think my daughter and I had 5 on our first day between the 2 of us, because I took us to the bathroom and I stripped her down and I searched her and shook out her clothes. My husband, who was in charge of searching himself, had 5 or 6 just on him, and he got one that he missed, and it bit him, and we found it a couple days later full of his blood. I'm sure that's in one of my tubes or bottles at home somewhere. I'll bring it in. And the dog had, because we didn't even check her, we couldn't keep up with it. So we pulled like 14 off her for the next week and a half. Because they'll hang out there and they'll feed for a week and a half easily. They'll just hang out there and slowly keep sucking. Okay, I can't do that anymore. Because it takes a while to get all the blood they need. Now, what's interesting is it's only the ladies you got to blame in the fall. The male deer tick only eats twice. The lady takes the 3rd meal. Why? For her babies! In terms of reproduction in most species, females have the higher energy requirements. Let's think about human pregnancy. Energy requirements for males to contribute to offspring. Pretty minimal. Doesn't take a whole lot. Doesn't take a lot of energy. Female energy requirements to contribute to an offspring. Oh, holy cow. It's 40 weeks of eating and making a whole nother human. Growing a whole nother human. That's freakish. Well, guess what the female tick is going to do? She's going to grow a whole bunch of eggs, and she's going to grow hundreds of them. And I actually have a video of it's so cool. I'll show you. So yeah, those nymphs wake up, take a meal, change. In the fall, those adults, if they're females, are going to bite one last thing. And that's usually a big thing. That's you or me or a deer or my poor dog. And then once they finish that meal, they drop off and they mate and then they die. And that's the way it is with a lot of species. Once you mate, your job's done. You can die. A lot of fish species do that. A lot of insect species do that. There are a lot of species where they don't provide any parental care. So once they've mated, that's it. They're finished. So the adult males will not bite you. They'll just climb on you. Because what they're looking for is a different sort of attachment. They are looking to crawl onto a female and mate. And once they're done mating, they die. And then you have 2 little dead ticks. Well, I'll show you what it looks like. This giant thing here, this hideous thing, that is a fully engorged female. Why is she dark? She is full of blood. And if you smash a tick on a rock, a fully engorged tick, as I have done many, many times, it is a big pocket of really thick, sort of semi-coagulated blood. Oh, they're enormous. This is a lady who got pulled off before she was done. She's like half full. So she's not as dark. You can still see a lot more of sort of her body structure over the blood. Once they get to that point, their actual body structure is pretty thin. It's like an overfilled water balloon. Yeah, it is like an overfilled water balloon. Put her on a rock, take another rock, and go smash, and it literally, you can hear it pop. Pop. Yeah, they pop really nicely. This is just a visual, and I'll put this graphic up on Classroom if you want to look at it. I think it's nice because it shows how this is a cyclical thing. You know, you have the eggs. This is spring, this upper quadrant. They hatch into larvae in, late spring, early summer. They take a blood meal, usually a mouse, usually a bird, something little. Then they change into nymphs. This is fall. They're dormant, they're dormant, they're dormant. They wake up. Whoops. Whoops, no. They're dormant, they're dormant, they're dormant. That's the blue line. They wake up. They take their second meal, meal number 2. And that's something bigger. It could be a deer, it could be a person, it could be another mouse, it could be a dog, it could be your horse, it could be anything. Then they molt into adults, and the adults take their final meal. And then if, just like with the deer we saw, if there were females who didn't mate early in the season, they get mated later. Adults that didn't get a good meal will actually take a meal in the winter. It happens. It's not common. Most of them are done in the fall, but there are a few hanging out there who haven't gotten to fulfill their destiny and reproduce and die. And then they lay their eggs. And that's it for them. So, one last thing. And I cannot remember, and I'm not going to pull up the spreadsheet right now. How many of you said that deer ticks have always been here? Do deer ticks kill deer? No. They don't do a thing. They suck some blood. It's not a whole lot of blood. This map, these two maps, this is the range of the black-legged tick. It is found in most of the eastern U.S. New England, all the way down the coast into Florida, Texas, Louisiana, Ohio, Indiana, all that. In 1998, which I think is before all of you were born, just a few years, that predates you by a few years, we didn't have a whole lot of deer ticks here. When I talk about pulling ticks off of me in college, me and my best friend in field botany pulling like 20 ticks off of us while everybody else is clean, those were all wood ticks. That's a bigger tick. That's a dermacenter tick, not an ioxid tick. That's the tick that's the size of a watermelon seed before it's eaten anything. Much bigger, much easier to see. These little deer ticks, well, look at the map. Will that expand? Of course not. Not when I want it to. Select. Okay. Look at that map. There's Ohio in 1998. Blue counties, and this is at the county level, blue counties have reported incidents of deer ticks. Red counties have established populations. We know we have them. We see them all the time. Is Columbiana County a blue county at this point? No, because we're right there. We don't even have reported deer ticks in 1998. I got my first deer tick in 2006, hiking in the Alleghenies. I was backpacking in the Alleghenies, and I came home with a deer tick. It was the first deer tick I had ever seen. I had pulled hundreds of dog ticks and wood ticks off me. I'd never seen a deer tick. And I backpack in West Virginia and Pennsylvania and up in the mountains fairly regularly, at that point in my life especially. Never seen one. Certainly wasn't going to get one in my backyard. Let's look at what happens by 2015. There's Columbiana County. What do you see? Whole lot of red. We have established tick populations, folks. In 17 years, we go from having no reported deer ticks to having well-established populations. Look at what happened to Pennsylvania. The entire state has established deer tick populations. I've gotten I currently live in sort of, suburban Pennsylvania. I live over towards Cranberry. I've gotten deer ticks off me in my backyard. Literally, come in the house and had a deer tick that was still walking on me. So literally, I must have just gotten it in the last few hours. It had not attached yet. It takes them a few hours to find a place to settle down and bite. And it literally had not attached, and I had not been any place but my own backyard that morning working out in the garden. Suburban Pennsylvania. Suburban Columbiana. I know somebody who had the same experience in Columbiana. She lives in a development in Columbiana. Working out in the garden, got a deer tick. Seriously? Get chickens, people. Get chickens. They eat ticks like crazy. Let them roam. You will not have any more tick problems. Yeah, so clearly something changed. Let's get that back over here. Something changed. Now, there is another species of tick, and you can see on this map, they color them. I didn't focus on it. It's another ioxid tick, same genus, different species. I forget what it's called, but it occupies the same niche. It feeds on the same kind of organisms, but it's just, that's the one we find there. Here we find the black-legged tick, and there are ioxid ticks all over the planet. You cannot escape them, the nasty little blood-sucking parasites. It's somebody you can actually call a blood-sucking parasite, and you're just being literal, just being scientifically correct. So there has been a 45% increase in counties in the eastern U.S. that report having ticks in the last 17 years. Seriously? Can we go back to not having deer ticks? I liked it. I liked not having deer ticks. Any questions that raises for anybody? I got a question. Why? Why are we now cursed with deer ticks? That's the cliffhanger we're going to answer for tomorrow. Right now, what I would like you to do is spend a few minutes sort of condensing your notes. A recall quiz on ticks should have just popped up on Classroom. Do not open it until you've looked over the notes. Take a minute. It'll probably be partially formative because I want to see if you got a few pieces. But look over the notes, look over the life cycle stuff, look over all that, and then you can take your quiz.